Scientists have searched high and low on this planet for materials left over from the creation of our solar system to no avail. Things have changed a lot over the past few billion years, so any material that was here is believed to have been destroyed or drastically changed. A team of researchers led by Director of Advanced Electron Microscopy Center at the Hawaii Institute of Geophysics and Planetology, Hope-A. Ishii looked beyond our atmosphere to get a closer look at the composition of interplanetary dust particles. For the first time ever, the particles were mapped down to nanometer-scale resolution, and Ishii and her team found that the dust contained the same organic carbons found in protoplanetary systems. In interplanetary dust particles originating from comets, we observe organic carbon mantles on subgrains within amorphous-silicate dominated grains called gems, glass with embedded metal and sulfides, the team wrote in a study recently published in PNAS. Our observations constrain gems grain formation to cold and radiation-rich environments, making a compelling case that these exotic grains, unique to our relatively obscure class of extraterrestrial material, are surviving dust from variable interstellar environments and thus the original building materials of planetary systems. The fact that the grains exist in the interplanetary dust is proof that the silicates weren't formed in the solar nebula from the condensation of high-temperature gas, but rather requires that they predated the solar system, according to Ethan Siegel of Forbes. That could just mean that we have to adjust our understanding of the silicates themselves, or it could mean an adjustment on a much larger scale. Our naive picture of a disk that gets very hot, fragments, and cools to then form planets may be hopelessly oversimplified, Siegel writes. Instead, we've learned that it may actually be cold outer material that holds the key to our planetary backyard. If the conclusions of the Ishii et al. Paper stand the test of time, we may have just revolutionized our understanding of how all planetary systems come into being. There is more work to be done to fully illuminate the earliest stages of solar system body formation, Ishii and her colleagues concluded in the study, adding that they hope their findings motivate further analyses and observations.